Hey there, interwebs. In The Big Bang Theory, Sheldon asserts that 73 is the best number, and he gives a few reasons for this. I just want to say, however, that he is completely correct and he only scratches the surface of its greatness. He said that it was the best because it is the 21st prime number and its mirror, 37, is the 12th prime number, 21's mirror. Furthermore, 21's prime factors are 7 and 3. Now, to continue his train of logic, 12's prime factors are 2, 2, and 3, which add up to 7, and 12's digits add up to 3. But wait, it gets better. He also boasts that 73 in binary is a palindrome, 100101, which, by the way, has 7 digits and 3 ones. Also, 21 in binary is 10101, another palindrome, and 7 in binary is 111, a third palindrome, and 3 is 11, yet another palindrome. In base 8, 73 is not only a palindrome, but the binary representation of 7, 111, and also the only prime reap unit. A reap unit is any reap digit consisting entirely of 1, and a reap digit is any number that uses only one unique digit. Also, if you take any 3-digit reap digit and divide by thrice the repeated digit, you get 37. If we look at 73 in Morse code, it is sent as 7 and 3, represented as dash dash dot 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 and dot 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 dash dash, making 73 as well as 37 Morse palindromes as well. 21 in Morse code is dot dot dash 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 dot dash 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 dash, which contains 7 dashes and 3 dots, as does 12. If we use an alphanumeric system where A equals 1, B equals 2, C equals 3, etc., G equals 7. Now, the ancient Greeks never had separate digits. They were using alphanumerics as their primary method of counting, and their G letter, gamma, was in fact 3. But this isn't Greek, it's English, which amusingly has 7 letters, and the third one is G. If you take 73 in base 4, you get 1021, which is the sum of 73's digits followed by the product of its digits. If you take 37 in base 4, you get 211, which is really just the same thing as 211.0, whose digits are the product of 37's digits followed by the sum of 37 digits. And that's a bit forced, I admit, but that's why 73 is better. 73 base 16 is equal to 37 base 36. Not only are these bases both square numbers, they're the squares of the first two composite numbers. Also, 36 is the square of the product of the first two primes, and 16 is the square of the product of the first two squares. This means that the product of 16 and 36 can be expressed simply as 4 factorial squared. But let's get back to 73, which, by the way, minus 36 is 37, and 37 minus 16 is, of course, 21. Impressive, but I would not be satisfied until I calculated it in hexadecimal, and 73 comes out to be 49. If we treat this as decimal 49, interesting things happen. First of all, 49 is a square number, and it's a prime number squared, and it's the first multi-digit square whose digits are squares. Its square root is the prime number 7. If you're not excited by all this yet, strap in. In due diligence, though, I also calculated 37 in hexadecimal, and it comes out to be 25. Again, if we treat this as decimal 25, we have another square number whose square root is a prime number, in this case 5, the prime just before 7. They're the third and the fourth prime numbers. Why am I making such a fuss about prime numbers? Because 73 and 37 are both permutable primes. This means they are prime numbers whose digits can be arranged in any permutation in which will always be another prime number. Do you follow me so far? Goldstar! No, really, because 73 is also a star number. That means it is a centered figurate number representing a hexagram, or 6-pointed star. Do you know what else is a star number? You guessed it, 37, which is also a centered hexagonal number. In fact, 37 and 73 are the third and the fourth star numbers. And now, finally, one last point to convince you of 73's superiority. 7 is the fourth prime number, and 3 is the second. 42. Thanks for watching, and have a nice numerical day.